Hi, and welcome back to a video series on MAT 1033 Intermediate Algebra. My name is Sean Perry. This is video number 9, Rational and Literal Equations. So the purpose of this video is to look at some other kinds of equations that we can solve using inverse operations. Last time we looked at linear equations. Before we get into rational and literal equations, I want to look at some other kinds of linear equations that are just as easy to solve, but they need a little prep work to get started. One of the ways that might happen is there might be some other variables involved, and really we're not going to treat these any differently than other terms which don't have an x in them from the last video. So for example, let's say we wanted to solve this following one for y. Notice that it is linear. There's only x to a first power, y to a first power, numbers, but there's no x times x, there's no x squareds, there's no x times y, and there's no division by variables either. So this is going to be a linear equation, and we're going to solve it the same way we did the other ones. The first step is to move everything that isn't a y, and we're trying to solve this one for y, right? So we want to move everything that isn't a y to the other side. Over on this side, I've got an x and a minus 6 and a y. So let's just start with this side. We can pick either side, but let's start with the left. And let's get rid of those other two terms. So I do their opposite operations. I do it on both sides. And using these inverse operations, we get cancellation on the left. So all I'm left with is 2y. And then over on this side, I have 4y, 10x minus 3x is 7x, and negative 7 plus 6 is minus 1. If we moved all the non-y's over to the other side, let's take the y's and move them over to the left-hand side. So to move the 4y, we take minus 4y from both sides, and that will cancel on this side and bring it over to this side, and 2 minus 4 is negative 2. Now we've got a coefficient of negative 2 in front of this y. If we divide by that coefficient, we're done. Make sure that you divide the entire side over here by negative 2 and not just the negative 1 at the end. That's done. This is done. So you could be done at this stage, but there's a nice trick. If I have a difference up top in a fraction and a negative on the bottom, I can actually get rid of that negative sign on the bottom just by reversing the order of subtraction up top. And the reason for this is quite simple. If you have a minus b, that's the same as negative b minus a. And then I have a negative over a negative, and they cancel. So if we want to simplify this just a little bit, we could switch the order of subtraction up top and get rid of one of our negative signs. That means writing it with fewer symbols, and that's generally better. Also, we could divide the 2 into each term. We could distribute the times 1/2 into each term. And then we would have this. This is another great trick to keep in mind. If you have a plus or minus b up top and a c on the bottom, you could always take and divide this into each term. Sometimes this is preferable. And in this way, we could write this as 2 separate fractions. I don't think any of these is truly preferable to the other, but there's some other ways that you might see the answer related. Now, there's other linear equations where we have a little bit more fiddling to do if we want to make it look like ax plus b equals cx plus d. Once we have it here, we talked in the last video about where to go, but how do we get here? Sometimes we might have to distribute and use combination of like terms to make that happen. So here's an example. Let's take 3x plus 2 times the quantity x minus 1, and that's equal to 4 times the quantity x minus 6 plus 7x. So the first thing we would do to kind of bring this into the right form here is distribute. If I distribute both of these outer terms of the parentheses inside the parentheses, we will have 3x plus 2 minus 2, and then 4x minus 24 plus 7x. Now we must combine like terms. We have a 2x and a 3x over here, that's 5x. We have a 4x and a 7x over here, that's 11x. And now it looks like ax plus b equals cx plus d. Now we're going to go the usual way of things. So the first thing that I would do is try to bring over the 5x. We'll bring that over as minus 5 and minus 5. That gets me 6x. If I bring the x's to the right, I want to take the numbers and bring them to the left. So we cancel 24 here by taking plus 24 and plus 24. Now, notice that this time I just did this in one step. Once you kind of get good at this, you can do that part in one step. Here I get 22. Here I get 6. And finally, we want to divide off that coefficient, reduce that fraction, and that's our final answer. So rational equations refer to equations where we're dividing by variables. If we have a variable in the denominator, that's actually no good if we're going to try to solve for that variable. Being in the denominator is something very different to being isolated. You can't just get rid of denominators where you feel they're not necessary. So we have to do something to get our variables out of the denominator whenever we're trying to solve for them and they happen to be there. We're going to look at a lot of rational functions later in the course, but right now we're going to look at simple rational equations which have linear expressions in the numerator and denominator. Here's a good example of one. Y equals 1 over 1 minus x, and I want you to solve this for x. Now we can't just start fiddling with things exactly as it is until we get that term, 1 minus x, out of the denominator. So the way you get things out of the denominator is you multiply by them on both sides. So here you can see that I have multiplied by 1 minus x on both sides. What does that do on this side? So on this side, it cancels. And on this side, well, we have 1 minus x times y. You still can't get at the x quite yet. You need to distribute the y against both terms. And when you do, you wind up with y minus yx is equal to 1. So we have some x terms here, and we also have this not x term. This has no x's in it, and we're trying to solve for x. So we need to move everything without an x over to the other side. If I do that, I wind up with a minus yx on this side, and we have, well, I don't know how to take y away from 1, so just write it down, 1 minus y. The only thing left to do is get rid of this other thing that's next to the x, which is a times negative y. So let's divide by negative y. And then we wind up with 1 minus y divided by negative y. You can rearrange that the same way that we did the last one, using our little flip the direction of the subtraction trick and getting rid of that sign. So now we are solved for x. There is just an x on this side, and it is alone. There are no x's on this side, so even if this looks a little freaky, we have indeed solved for x. So the term literal equation refers to any equation that comes from formula related to like real problems. As various as real problems can be, so are their formula. So all sorts of stuff might be happening here, and in fact, we might not even be able to solve it if it's a complicated enough equation. However, we are going to look at equations where we are going to be able to solve it using inverse operations. So for the problems in this course, we're still going to solve these equations the same way. And here's a little step-by-step of what we've been doing. We identify the variable that we are trying to solve for. We try to isolate that variable, and the way that the move that we use to isolate that variable is by doing inverse operations on both sides. So here's a fun one. Let's take the ideal gas law. Pressure times volume equals number of moles times the constant R times temperature T in Kelvin. You don't have to know what that means in order to work with the algebra. And vice versa, even if you know what it means, if it's not solved for the variable you're interested in and you don't know algebra, you're kind of out of luck. So let's talk about just the algebra that would be required if we wanted to solve for R here. So the main idea, let's start by identifying the variable that we are trying to solve for, R. And also notice that the operations that are tying it to its partners here are multiplication. This is n times R times t. So if we want to get rid of those n's and t's on that side, we need to do the opposite of times n and times t. So dividing by n and dividing by t, which I'm doing in one step here, they cancel from this side and they appear on this side as division. And is this solved? Well, R is alone. There's no other R's. Ball. This is done. So that's the main idea here, is that you are basically identifying your variable and using inverse operations. You do it to both sides, you cancel what you can, and you keep chipping away at what's around your variable until you get to it itself. Now, some work might be necessary before you can do that, things like distributing or combining like terms. Let's try a couple of those out with today's praxis. I want you to try these exercises out and copy them down as validation that you watched the video. Now, take a couple minutes and try these for yourself. Okie dokie, let's see how it went. To start with number one, we're going to need to distribute first. And we're going to have a little distribution to do on both sides. So let's take care of that first. We bring the 2 in against the x, against the -4. We bring the -3, its minus sign is attached to the 3, against the x and the -9. So by our sign rules over here, that's going to be positive 27 and minus 3x. Over here on this side, it's 2x and -8. Now we find the x's on this side and combine them. That's 5x total. And on this side, we have 27 and 7 that we would know how to combine to get 34. So to continue, we need to pick a side and move all of my x's to that side. In this case, what I've done is I'm canceling the x terms on the right-hand side and moving it to the left. And if I move the x's from right to left, I'm going to take the non-x's, the numbers in this case, and move it from left to right. So that's me adding 8 on both sides here. It cancels the 8 on this side, and it moves it to the other side. But when all the dust settles on that, notice that we have the x's and the non-x's separated. That's the idea. All that's left to do to finish this problem is to divide off the coefficient. We're timesing 8 by x here, so we divide by 8, and that gets us 42 over 8, which simplifies to 21 over 2. For the next one, we're going to want to first get this x minus 4 off the denominator. Remember, if you see some fractions, the first thing we should do is get rid of those fractions. And you get rid of fractions by multiplying on both sides by the denominator. So the denominator is x minus 4. I multiply on both sides by x minus 4. Now, once I multiply on both sides by x minus 4, the x minus 4's cancel here to 1. And over here, I'm going to need to distribute the y against both terms. Once I do that, I'll get x times y minus 4 times y. And that is equal to the numerator here is all that's left, 4x plus 5. We pick a side, we move all of the x's to that side. In this case, what I'm going to do is I'm going to move the x's from right to left. This term has an x in it. I'm going to leave it right here. This one has an x in it. I'm going to minus it in order to cancel it to 0 on this side and move it to the left. If I move the x's from right to left, I'm going to want to take the not x's, everything without an x, and move it from left to right. So I do that by adding 4y, that's the opposite of minus 4y, and I move it over to this side. Cancels here, adds here. Now you can't really add 5 and 4y, so just leave them. Just leave them together. If you can't do something in algebra, just write it down. You don't combine what you can't combine. You can't combine unlike terms by addition or subtraction, so we just write it. And over here, I have xy minus 4x. I've highlighted the x's to emphasize what we do next, which is to factor out that common x. Once we factor out the common x, we have x almost isolated here. The only thing that's left is to divide away what's multiplying the x. It's being multiplied by by y minus 4, so I divide on both sides by y minus 4. And again, that cancels on this side. It cancels to 1, and you're just left with x. And on this side, well, this is the great thing about algebra, people. If we don't know how to evaluate it, we just write it. I just write divide by y minus 4, and I leave it like that. And this is actually our answer. We are done. X is alone, and there's no x's on this side. So this is done. We have solved for x. All right, last one. So this one, I intentionally made this term a little freaky looking because, oh, there's 3's and p's and q's and y's and 4's, and it's all just multiplying by x. So I just wanted to take a moment here and sort of color code the players. We've got a term that's multiplying this x. We've got a term minus 7 that's multiplying this x. We're subtracting the minus 7x from this thing here. And then we've got a plus 9. So two of them have x's, one of them doesn't. Let's move that guy over to the other side. We want x's on one side and non-x's on the other side. So we move that guy over. And now I have terms that each one of them has an x in it. That means I can factor out x, and then x is being multiplied by this expression, 3pq over 4y minus 7. Okay, well, if I want to get rid of something that's multiplying, all I have to do is divide by it on both sides. On this side, it cancels, and on this side, it persists. And I don't need to write anything different. I have minus 9 divided by this term that was multiplying the x, and that's it. We're done. I mean, this is your answer. We can be done with it at this point. Now, there's a bunch of different ways to write this. You could combine the 7 with this term. I'll work on stuff like that a little bit later, ideas about simplification and all that. But for right now, are we solved? Yeah, the x is alone. All the other stuff is pushed to the other side, and there are no x's over here. So we have solved for x. This is a valid answer. Okay, that concludes the video. Thank you for your patience. Have a great day, and good luck with your studies.